Alright, so our topic for today is all about combinations. Okay, so after permutations, okay, you will know, okay, again, another topic prior to probability. This is a combination. So, these are the competencies. Illustrate the combination of objects, differentiate permutation from combinations. Yeah, so let's recall, answer the following tasks. This is prior to permutation. In how many ways can six children be seated in a row of six chairs? So just taken all at a time. So 6 so is equal to 6 factorial. So 6, 5, 4, 3, 2, 1. Just get a product. So the answer is 720. Thus, the six children can be seated in a row of six chairs and in 720 different ways. Okay. Number 2, a bus has 6 vacant seats in the last row. If 2 additional passengers enter the bus, and how many ways can they be seated? So the totality of seats is 6. Then if 2 additional passengers enter the bus, so another 2 additional passengers, so we have the condition. So and 6 R's 2, so 6p2, so applying the formula for the permutation, so n factorial all over the quantity of n minus r factorial. So 6 factorial all over 6 minus 2 factorial. So 6 factorial is all over 6 minus 2 is 4. Copy the factorial symbol. So 6 factorial all over 4 factorial. So 6 times 5 times 4. Then all over 4 factorial. Cross out the remaining 6 times 5. So we have the product of 30. Thus, 2 passengers can be seated in 30 different ways. Okay, next, how many different signals, each consisting of 8 lighted colored bulbs arranged vertically, can be formed from a set of 4 blue bulbs, 3 red bulbs, and a yellow bulb. So N is 8, total number of bulbs. A is 4 blue, B is 3 red, C is 1 yellow. So 8 factorial all over 4 factorial, 3 factorial. So 8 times 7 going to 4, 4 times 3 times 2 times 1. So it cross out 4 factorial. So the answer is 280. Thus, 8 bulbs can form 280 different signals. So combination is a selection made from a group of items whose order is not important. The number of combinations of n things taken at a time is given by n0 is equal to n factorial n over n minus r factorial times r factorial. So this is about selection. Example, evaluate 5C2. Solution n is equal to 5 and r is equal to 2. So 5 factorial all over 5 minus factorial 2 factorial, so is equal to 5 factorial all over 3 factorial 2 factorial is equal to 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1 times 2 times 1. So cross out, 5 times 4 is 20, 2 times 1 is 2, so 20 divided by 2 is 10. So that's how to evaluate. Number 2, evaluate 10C3. N is equal to 10, or r is 3. So 10 factorial all over the quantity of 10 minus 3 factorial 3 times 3 factorial is equal to 10 factorial all over 10 minus 3 is 7 factorial. Then that 3 factorial. So evaluating that, so it will give us 36 million, no, 3,628,800 all over 30,240. So upon dividing, will give you 120. So combination C of n objects taken one or more at a time is given by C is equal to 2 raised to n minus 1. So again, this is property of n objects taken one or more at a time. So C is equal to NC1 plus NC2 plus NC3 go to NCn. Example, how many ways can you invite 6 friends to attend your birthday party? Note you can invite one friend only, two, three, four, five, or all of 6 of them. So NC1 plus NC2 NC3 going to NCn. C is equals to 6 C1 plus 6 C2 plus 6 C3 plus 6 C4 plus 6 C5 plus 6 C6. C is equal to 6 plus 15 plus 20 plus 6 plus 15 plus 1. C is equal to 63 ways. C is equal to 2 raised to n minus 1. So C is equal to 2 raised to 6 minus 1. So C is equal to 64 minus 1. C is equal to 63 ways. Right. So you can use this one, or you can use this formula finding the result. How many polygons can possibly be formed from 6 distinct points on a plane, when no three of which are collinear? Polygons can be made in various ways. It can be made using at least 3 points, triangle, 4, 5, or all 6 points. What is combinations here, but we can start with NC1 since the polygon must at least have 3 non-collinear points. So C is equal to 63 plus 64 plus 65 plus 66. C is equal to 20 plus 15 plus 6 plus 1. C is equal to 42 polygons. Alright, so what is the difference, or what are the difference of permutations and combinations? So from the concept or context of permutation, this is about an arrangement, while the combination is about selection of objects. So again, a selection of one objects taken at a time in which order is important. This is permutation. So when order is very important or arrangement is important, this is permutations. A selection of n objects taken at a time in which order is not important, and this is combination. Alright, so yeah, determine whether the following test is permutation or combination. Picking 3 winners out of 20 participants in a raffle draw. Here is your answer. Since the order of 3 winners is not important, it is combination, and to solve it you will evaluate 20 situations. So here uh, the keyword here is this picking 3 winners out of 20 participants. So this is a problem prior to combination. Okay, and next. Determine the Miss Universe winner, first runner-up and second runner-up out of 20 contestants. So here, order is very important because in determining the Miss Universe, so we have this sequence, we have this ranking. So since a specific ranking of the winners were mentioned, 20p3, it means the order is important, and therefore this is permutation. And to solve it, you will evaluate 20p3. Alright, so hello guys, this is about the combinations, and here we are answering whether this is a permutation or combination problem. So guys, if you're new to this channel, don't forget to subscribe for more videos like this, okay, that imparts knowledge prior to the lesson combination. So again, if it's about arrangement and order is very important, this is permutation. And if it's about picking, selecting or selection of an object, and arrangement is not or order is not important, then this is about combination. Thank you in advance.